this is the problem 1. And for this problem, we need to explain the process. And for the first one is Poisson process, and is divided by following properties. And the probability is like this, and the number nt1, t2 of the points ti in the interval t1 to t2, from t1 to t2, and the length is t2 minus t1. And we can note that this process, the mean is lambda times t. Oh, it's lambda times t here. And the first order probability method is this. And we also have the property that if the intervals t1 from t1 to t2 and t3 to t4, they are non-overlapping, then this and this are independent. And we also have property that at a time moment t, there is no more than one Poisson point. And we also have, using the points ti, we can form the stochastic process xt is equal to n0 to t. It's like this graph. And we have autocorrelation is this, and autocovariance is this. And for the question 2, we talk about the Poisson increment process, and it's defined by this. And its first order probability method is this, and mean is this. It's a constant, and it's autocorrelation, and when this is greater than epsilon is this, and less than epsilon is this. And for autocovariance is this value. And for the question 3, Poisson impulse process is defined by this. Is a derivative of Poisson process. And the graph is like this, and now it isn't defined. The probability method is not defined, so we don't have it. And for the mean, the expected of Zt is lambda is a constant, and this is correlation, this is covariance. And for the question 2, semi-random telegraph signal is also based on Poisson points. So the probability is this, and xt is 1 when k is even, and -1 k is odd. In the interval O to T, and we get first order probability masses is this. When xt is equal to 1 is this, xt is equal to minus 1 is this, and the mean is e, and the power of this, and this is correlation, this is the covariance. And the question 5, random telegraph signal. For this is like this, the formula is the form is like this, and the probability of A is equal to 1 is equal to the probability of A is equal to minus 1 is equal to 1 over 2. This is the probability of A. And xt is a semi-random telegraph signal. So for the first order probability masses, probability when is equal, yt is equal to 1. So A is equal to 1, xt is equal to 1, or A is equal to minus 1, xt is equal to minus 1. So is 1 over 2, and for this is A is 1, xt is minus 1, or A is minus 1, xt is 1. So we can get yt is equal to minus 1. So it's also 1 over 2. And the mean is this. The autocorrelation is this. Autocovariance is this. And for random walk, in this we toast a fair core n times, and k is the number of heads. So we can get this x and t. The probability masses is this. The mean is 0. And this is the correlation, this is the covariance. Minor process is also this. And when t is close to 0 and this is close to a, n is close to infinite, xt is random walk. So this form is linear process, and we have density function is this, and the mean is 0. This is correlation, this is the autocovariance. This is autocorrelation.